Just like we did with the quadratic stuff yesterday, we worked with writing cubic functions just like we did writing quadratic functions via their intercepts. One of the things I want to remind you guys about with cubic functions is how many zeros will a cubic function have? Three of them. How many terms will have a cubic function? Four. How many changes of direction can a cubic function have? Two. Remember, degree, 1 plus your degree is your number of terms. The degree is the number of possible zeros. 1 minus the degree is the possible changes of direction. Okay? So in a cubic function, what we have is this generic equation which looks very similar to the zeros equation for quadratic. And when we look at it in terms of a polynomial, or a cubic one, excuse me, and we want to write out the equation, we're going to do basically the exact same thing. You're going to have to know 3 of the zeros and some other point not a zero. Really want to get class. So if I'm looking at this, what are my 3 zeros?
Negative 3, negative 1, and 3.
So if my zeros are at negative 3, negative 1, and 3, my terms are plus 3, plus 1, minus 3. Just like they always were when we were doing polynomials way back in the day.
What's your term? Is it like 7, P, Q, R?
Okay. For some. Yeah, Peter, Queen, Roosevelt. What's the other ordered pair that we have then? Negative 2 and 1. So what you wind up doing is substituting in and solving for A. This is and you get 1/5 when you do it, when you go through it. So once you get the A value, what do you do with the A value?
Plug it back in.
Well, you would substitute back in, because we're not doing electrical work right now.
Yeah, that's
Can we do that later?
Sure. Make sure you're standing in water. You're right. Top tip, don't stand in water while you're working with electricity.
Don't fall for peer pressure, don't do it.
And there's your function. Okay? And now we go back to the new stuff. The new stuff is when you don't know what the degree of the polynomial is. Well, there's a way in order for us to be able to look at a set of data points to be able to figure out what the degree is going to be. One of the crude ways of doing it is counting changes of direction. Doesn't always work, because remember sometimes with a 4th degree polynomial, it could just be like similar to a parabola, because you can have imaginary solutions. So sometimes that doesn't work. But when we're talking about something in a regular style polynomial, we use what's called finite differences. And in order to use finite differences, this is how to tell the degree of a function. And it's basically subtracting values. What's happening here is that you have some input output, some x, some y value. Some function, when you substitute in for x, you're generating out a y value. A lot of times we call that f of x. So basically what it means is that if I substitute in 1 into some equation, I'm going to get negative 1. If I substitute in 2, I'm going to get 3, and so on and so forth. That's what that means. In order for us to figure out the polynomial degree, we're going to find the finite differences, which means eventually we're going to get the same number when you're subtracting out. Here's how you do this. When you have your stuff set up in a table form, you take your f of x values, and you're going to find the difference between them. 3 minus negative 1. 3 minus 3. 5 minus 3. 15 minus 5. 39 minus 15. 14. So we've done it once. Are those numbers the same?
No.
Let's do it again. Yes, ma'am.
Way to go, Sam.
Wait, what are we doing?
Oh,
Subtracting
24.
the second number from the first?
Yep.
A good job. 4 is.
Thanks, Sam. We do it again. What's 0 minus 4? 2 minus 0. 10 minus 2. 24 minus 10.
14. Nice.
Hey, are all those numbers the same?
No.
Let's do it again.
Less
This is
4.
Illuminati. This is the devil's problem. Illuminati.
666.
What's 2
Okay.
minus negative 4?
6. Oh my god.
8 minus 2.
Oh my god.
Oh no.
14 minus 6. Or minus 8.
6.
So, are all 3 of those numbers the same? So, that means we've done it once, twice, but thrice.
3 times. 3 sides to a triangle.
So, what's the degree of this polynomial? It's a
Illuminati.
3rd degree polynomial.
Triangle
It's the Illuminati.
This is Illuminati's problem.
Oh, the third.
Yeah, there's 3 sides to a triangle.
So, there's a 3rd degree polynomial, but a 3rd degree polynomial has up to how many terms in its equation? 4. So what we can do is we can actually figure out what equation this is without too much of a hassle. We know that it's going to follow some rule of ax squared plus x cubed plus bx squared plus cx plus d has to equal some value of y. Okay. Since I know that it has to be a 3rd degree polynomial, and I'm going to have 4 terms, how many of these values am I going to use into there?
All of them.
4 of them.
4 of them.
The reason that it's 4 because 3rd degree has 4 terms. If it was a 5th degree, I would use 6 terms. If it was a 2nd degree, I would use 3 of them. So what I'm doing here is I'm going to wind up generating. Let me put this on the clean one here. I'm gonna take and create a 4x4 matrix.
A 4x4 matrix.
I know. It's getting dicey in here.
Oh no.
Remember, here's your value of x, and here's your value of y. You're going to use the matrix to solve for A, B, C, and D.
No.
Why am I putting 1 in front of the D all the way down?
Because there's no coefficient.
Correct.
Terminal.
And now we go back and create a 4x4 matrix, and we're putting in the coefficients. Okay? And what am I going to put for my solution matrix? put that in my calculator, it's gonna give me my A, B, C, and D. It's a nice, quick way to decide which way to do it. All right? But wait, there's more.
Did you see that?
Now you can do it this way, which is fine.
I like it.
All right.
Wait, this way.
Yo,
You just pulled those off of the chart. That was-
Yeah.
So like,
those are your X's and your Y's.
for like, it was like 1, 2, 3, 4, and then Y was here.
Mhm. Another thing I can do is this. What was it? -1, 3, 3, 5. I know that this has to be a cubic function because it's third degree. But stay off the phone. Just put it away, man. You're always on
See
it.
when I have to take my meds.
Go back to your stat and hit the calculate button. And it's got to be, we know this has to be cubic because we found out by using our finite differences that it's third degree. It's 6. There's your A, B's, and C, and D. Isn't that the same answers you guys got from your matrix? We knew it's got to be cubic. This is third degree.
How do you do that? I was doing the matrix while I did that.
What's that?
I was putting this up into the matrix while you were doing that.
I just did L1, L2.
Okay, so you put.
I did L1, L2, then I went cubic regression.
Okay, so you put in the x for L1 and the f of x for L2.
Yes, sir. It works for anyone that you have a table, whether it's a cubic, quadratic, or anything. This is just a faster way to do it with L1, L2. So I had to show you both ways because yeah, that's how I roll. It does. It's doing the exact same things the matrix is. It's just faster.
Yeah, like.
Why do we have to do the matrix?
Why not?
So we can do both.
Right.
Which one?
And then you hit edit, and then
Let me show you another one.
That's a lot quicker.
Cubic.
Let's try another finite difference.
Wait, hold on, Mr. Murphy. How do the answers that you get out of the matrices apply to the?
A, B, C, and D.
It's just going from top to bottom?
Yes, sir.
Okay, thank you.
What's that? Ah, remember, this is f of x equals 1. So that means f of 1 is 1. So this is your x's are 1, 2, 3, and so on. And your f of x is 1, 4, 10, and so on. So what we do here is the same basic idea. We're going to take 1, 4, 10, 20, 35, 56, and 84. And we're going to figure out which regression model we're going to use by finding their finite differences. So 1, 4, 10, 20, 35, 56, 84, and just work our way through it. What is 4 minus 3? Or
3.
10 minus 4.
Sure.
20 minus 10. 35 minus 20.
Don't tell me, don't tell me.
What is it?
What's what?
28.
28. Okay. Are those the same numbers?
Yes.
No! There's 1. Which means it's not linear. If those were all the same numbers, they would have a common difference. Therefore, it would have been an arithmetic sequence, which is linear. They all have the same slope. 6 minus 3. 10 minus 6.
5.
3.
7.
Oh! Are those the same?
No.
I don't think so. I wonder what the next one is going to
It's
be.
probably 666.
I don't know. No, it's not. Are all those numbers the same?
Yes.
What's the degree of a polynomial?
Third.
Third degree polynomial. So this is a third degree polynomial, which means that once you get a finite difference all being the same, we know we can use our regression for x being in your L1, f of x in L2. Yes, sir.
How is it a third degree polynomial?
Because it took me 3 times to subtract out to get the same values. That's basically where this comes from. Let's try it again. You dying? You all right?
I'm kind
You gotta live when you're dying.
Let's try this one.
It's a song.
You need to get some water. Go ahead. What is 15 minus 6?
9.
Don't sit that close to shit.
Sam's contagious.
22 minus 15.
3.
Good job.
You're getting too close to her too.
Oh, I'm pretty good at that.
21 minus 22. 6 minus 21. Negative 29 minus 6.
Negative 35.
Bless you.
Oh, this next one is.
Are those the same? No.
If you close your eyes, they are.
7 minus 9.
2.
Negative 1 minus 7.
Negative 8.
Negative 15 minus negative 1.
Negative 14.
Oh, it's.
All right, Coop, figure this. Negative 15 minus negative 15. Wait, negative 30. I can't even say it right. Negative 35 minus
Oh no.
negative 15.
You add the 15, so it's negative 20.
Right.
I was gonna say, like,
I was about to say negative 15 minus negative 15. Well, it's 0, right? Go on.
Negative 0. It's negative 0.
Are those
It's
numbers the
happening
same?
again.
no.
So we do it again.
Oh no.
Oh, no.
What is negative 8 minus negative 2?
Oh my gosh, you're about to.
Negative 14
No,
minus negative 8.
Negative 6.
He has the evil look in his eye.
We're being done.
He knows what he's
Negative
doing.
20 minus negative 14.
Negative 6.
We have a negative devil in here.
So does that mean it's like good then?
Yeah!
No.
I was just saying it's the anti. The anti-devil.
Does that mean math is the anti-devil?
Sure.
Or does that mean math is the devil itself?
Or it just means that it's a third degree polynomial with a finite difference of negative 6.
No, it is
Does
a triangle.
this equation calculus?
Why would it be that?
This is the second time it's happened today. That's not a coincidence.
No, it's not. It probably happens a lot more than you think. Me? Not this.
Yeah.
He
does
worships
radicals.
the devil.
Oh, yeah.
Sells his soul to the devil.
To be a math, to be a.
Should we do, all right, figure out this one and then use the regression to write the equation, then we'll call it a day.
What was regression?
Calculate.
Good old calculus.
So awesome.
No, without
Oh,
that.
Claire's great. Let's see, what is this? -5.
So you can.
He was kicked off by a horse. So he was kicked in the head by a horse. I think it was.
Hey, this one's only half as bad as the others.
Got it.
I'll get it.
Are these all gonna be third polynomial?
Some of them will be second degree. I think that, I don't know if there's 4-3 in here or not, but we can do this 4-3 as well.
Would it ever happen where you just get just one, or would you be doing it wrong?
Oh, if you do it once, that just
Yeah.
means it's linear.
No, I mean, if you go all the way down, so you end up with just one number, would that be a fifth degree?
I mean, I guess you could. It could happen. What was your equation then?
I got half x cubed minus 4x squared plus 3.5x minus 3 equals y.
Does that seem close-ishness? Yes, sir.
This kind of like sidetrack.
We never get off track
But
here.
with
You
what
should
you're
know better than
saying,
that.
If you got down to 1, wouldn't you need to find the next term to see if it was the same?
Yeah,
Or
but they wind up with a common difference at the end.
Because like, wouldn't you, if you had 6 terms at the beginning and you filed it down to 1, then it would always be fifth degree one. And
I'm
if you
trying
had
to-
7, you filed it down to that same and it wasn't the same, then
I'm trying to think if we have anything at all that we could check that off of. Polynomials was chapter 6, correct?
Sure.
I wonder if we could do that out of a higher degree polynomial. These are only fourth degree stuff. What's that? I think you guys go at 30. Because I remember I think there was an email about that. at some point. Let me look at that, see if I can find a problem that we can make that work. Let me give you guys some problem real quick.
I'm just thinking.
So this was what, 6, 9, so this is here. Let's do,
11
I know, I
through
was
13.
what I do, 18 and 20. I think that's what I had from the other
That's
earlier.
it? 18 and 20?
Oh, God, no.
I'm fine with that.
It was 18, 20, and then it was, I think it was 32 through 42 evens,
No? I think it was just.
and then 47, 48, yeah. 32 through 42 even,
Yeah.
and then what I say, 36, 47, 48. Sorry about that, I didn't write this down. All right,
How do you clear up?
clear list.
Yeah.
Second plus 4. All right, work on those. You're gonna get 90% of it done before you walk out of here. What's up? Yeah, let me compile this and I'll walk you back through it.
Right away.